Okay, in this question we're given a graph of a function and we're asked to determine the inverse graphically, then to state the domain and range of each. So we begin with this parabola that opens down. In order to determine the inverse, we'd like to know the coordinates of at least one point, but more is better. And what we see is that we have the points -1, 2, 0, 5, 1, 6, 2, 5, and 3, 2. And so our inverse is going to have the points 2, -1, 5, 0, 6, 1, 5, 2, and 2, 3. And there we go. Well, our vertex is 1, 6, and we open through all the rest of the points, so our new vertex will be 6, 1, and we'll open through all the rest of the points. The reflection of a parabola is a parabola. And so this is what we get. Okay, now if we were to look at it in the line y equals x, if we were to imagine that diagonal line drawn through here, we would see that we in fact do have a reflection. This parabola reflects onto this sideways opening parabola. We're then asked to determine the domain and range of each. Well, we see that the original, we have the domain x is an element of the reals, and the range is y less than or equal to 6, and y is an element of the reals. Well, the domain of the red curve, the inverse, is going to be x less than or equal to 6, and y is an element of the reals. And notice what's happened. The domain of the inverse is the range of the original, save for the fact that we switched the letters from x to y. And the range of the inverse is the domain of the original, save for the fact that we switched from x to y.